In this video, we're going to review snapshot C-CO.14. This is where we want to prove geometric theorems, apply properties, definitions, and theorems of 2D figures to prove geometric theorems and solve problems. And make sure my volume's up. All right, so for question number 1, it says this diagram shows parallelogram TUVW. And they want us to figure out what is TV. So we have some options. But let's take a look. If we know this is a parallelogram, we know that diagonals bisect each other. So therefore, we know that these two pieces, they've labeled 3x plus 6 for TO and 4x plus 1 for OV, would be congruent to one another. So let's start by setting those up as equal so we can solve for x. So to solve for x, you want to move the variables on the same side, but move the one that has a smaller coefficient. So I'm going to subtract the 3x from both sides, and I get 6 equals x plus 1. Then I just need to subtract 1, and I get x equals 5. But then let's look at what they're asking us for. They want, what is TV? So TV is the entire diagonal. So we're going to plug in x and figure out what that would be. So I'm going to say 4 times 5 plus 1 will give me 21. And then I know that those are both equal to the same thing. So 21 plus 21 will give me D, which is 42. All right, let's look at question number 2. It says this diagram shows rhombus PQRS, and we want to know what is the length of QS. So again, QS is this whole diagonal of the rhombus. And we know in a rhombus, it's a parallelogram, so the diagonals bisect each other again. So those two pieces are congruent, and then QT would be congruent to TS. So let's set up the blue ones. So I'm going to say 7x plus 3 is equal to 7y minus 11. And then also x plus 12 would equal 5y minus 13. But what I notice is we have x's and y's mixed together in the same equation, and we can't solve for x or y until we get it so that it only has one variable in the equation. So something we can do in math is solve for a variable and then plug it into the other equation. So what I can see is x right here in this second equation would not be too difficult to get by itself because it's just added to the 12. So I'm going to subtract the 12 over, and then I quickly get that x by itself. So x would equal 5y minus 25. And then I can take that value for x, and I can plug it into the first equation to help me get everything in terms of y. Because I'll have 7 now times 5y minus 25, because we know that's equal to x in this problem. Then that's still going to equal 7y minus 11. So I substituted what we got for x in that first equation. So then I need to solve for y. So I'm going to distribute the 7, and I get 35y minus 175 equals 7y minus 11. Then we always like to move the variable on the same side by moving the one with the smaller coefficient. So I'm going to subtract 7y. And I get 28y minus 175 equals negative 11. I'm going to then add the 175. So I get 28y is going to equal 161. And then I can divide both sides by 28. And y will equal 5.75. So I look back over at the problem, and I need to figure out QS. So now I know that y right here is equal to 5.75. And when I find this piece, I know it's congruent to the other piece of the diagonal. So then I can figure out the whole thing. So I'm going to plug in 5 times y, which is 5.75, minus 13, which gives me 15.75. Which I know they both equal that. And so then all together, 15.75 let me put 15.75 times 2, or if I add them together, I get 31.5. So my answer to this one is C. All right, question 3 says the perimeter of this rhombus is 32 centimeters and WY equals 7 centimeters. And it wants to know what is VX. So VX is once again the entire diagonal of this rhombus. But we need to know what these pieces are in order to figure out that diagonal. And we know inside of a rhombus, the diagonals are perpendicular to one another, so it creates 90-degree angles in the middle where they intersect. And then we know that WY was given, and that's 7. And the other thing we know is the perimeter of this rhombus is 32. So perimeter means to add all the sides of the rhombus. So if they all equal 32, and we know that they're all congruent to one another, then we just got to do 32 divided by 4 to get what each side would be, which would be 8 centimeters on each side. But really the main one we need to focus on is up here at the top, because we're going to use this right triangle to solve for that half of the diagonal, and then we can figure out the whole diagonal. So I'm going to figure out this side using the Pythagorean theorem. So I'm going to put together a squared plus 7 squared equals 8 squared, because that is the hypotenuse in this case. And then I'm just going to subtract over the 7 squared. So I get a squared equals 8 squared minus 7 squared. So a squared will equal 64 minus 49. And then that gives us 15. So then a, or that half of the diagonal that we're looking for right there, would be the square root of 15. But then we got to put together 2 of those. So that is why the answer is B. 2 square root 15 is going to equal the whole diagonal VX. All right, let's look at one more. In rectangle G-CO.14, the diagonals intersect at point M. They have not drawn a diagonal, so I am going to draw a rectangle, and then I'm going to put in the diagonal. So let's call this rectangle G-CO.14, and then the diagonals intersect at point M, is what they said. And they said the length of JL, so let's highlight, JL is this entire diagonal, and that is given as 2x plus 54. And then the length of segment, let me get another color, segment KP, which is the other diagonal, is given as 8x plus 42. So we know with a rectangle the diagonals are congruent, so that'll probably be helpful. But let's see, they want us to find the length of segment PM. So that'll just be half of a diagonal. And in a rectangle, we actually know that the diagonals bisect each other and they are congruent. So all 4 of these pieces right here would all be congruent to one another. But then the whole diagonal would also be congruent to the other entire diagonal. So let's set up 8x plus 42 would be equal to 2x plus 54. Let's subtract 2x. So we get 6x plus 42 equals 54. Subtract 42, so 6x will equal 12. And divide by 6, so x will equal 2. Now we just need to plug it back in. So I'm going to plug it back into the 2 times x. So 2 times 2 plus 54 is 4 plus 54, which is 58. But then we only need half of the diagonal, because we're looking for PM right here. And so 58 divided by 2 will give us 29. So the answer would be C. All right, so that's it for this standard.